Time is not real. Why the universe is deleting your past. Your past isn't stored. It's compressed or deleted unless someone is asking for it. That sounds reckless until you notice the receipts, heat released when memories are erased, records that decide whether a particle interferes or behaves, horizons that cap the bits you can ever retrieve. Here's the thing: evidence has been hiding in plain sight, from lab benches to the edge of the sky. Tonight we test 3 questions: what the universe keeps, what it throws away, and how you can tell the difference. The stakes are personal: identity, memory, meaning. To see the glitch, we start with the lag in your own head. Latency of now. Your present is already a memory. The first time Benjamin Libet asked volunteers to flex a finger whenever they felt like it, he wasn't hunting metaphysics. He wired scalps, watched the oscilloscope, and found a faint ramp in brain activity long before anyone reported deciding. A slow readiness potential rose hundreds of milliseconds ahead of the twitch. The line moved first. The feeling came later. Get this, the delay wasn't a rounding error. Across sessions, readiness potentials often began roughly 550 to 800 milliseconds before motion in pre-planned acts, and the reported intention to move, W, in Libet's clock, showed up about 200 milliseconds before the muscle fired. In spontaneous acts without pre-planning, the brain's ramp still led conscious intention by about 350 milliseconds. Later work used the lateralized readiness potential to track which hand the brain was preparing. That signal kicked off more than 700 milliseconds before movement, while participants reported awareness only around 350 milliseconds before, confirming the gap. Consciousness arrives late and stamps now on events already underway. What nobody knew at the time was how that lag would feel once you lived with it. Your present is post-processed. The nervous system buffers and backdates to keep the world aligned. Vision integrates over tens to hundreds of milliseconds. At low intensities, direct cortical stimulation can require 350–500 milliseconds before a sensation reaches awareness. You move on prediction and correction, an error-minimizing loop that fills blind spots and smooths asynchronies so your story won't tear. Micro story. A pianist runs a fast passage she's played for years. The left hand slips. She swears she felt the mistake the instant it happened. EMG leads say her muscles fired before she knew. Her correction lands inside the final 100–200 milliseconds, a Vito window Libet highlighted where action can still be canceled. The choice to stop is real. The first spark was earlier. Now scale the latency. The speed of light doesn't just cap signals, it sets the sync rate for reality. Every now is cone-shaped, a mosaic of older scenes stitched to fresher local events. The star you admire is centuries late. Your hands are a few milliseconds behind nerves. The room around you is nanoseconds ahead of the street outside. There is no single global render. There are mosaics assembled from what could arrive in time. Meanwhile, the physics of forgetting quietly charges rent. Rolf Landauer pinned the bill in 1961. Erasing 1 bit dissipates at least kT/ln2 of heat to the environment. Charles Bennett later showed computation can, in principle, be reversible if you don't throw branches away. But the moment you reset or merge paths, you pay. Information is physical. Forgetting burns. Brains learn the rule the hard way. They run on about 20 watts and get miracles by compressing. Predictive coding throws away expected input and spikes for surprise. Memory consolidates gist, not tape. You can feel the ledger in ordinary life. The exact phrasing of a conversation dissolves. The meaning remains. Redundancy stabilizes what matters. The rest fades. Stakes sneak in here. If the felt present is already a memory, then your past is a product too. It persists when it's redundantly written. Synapses, notes, photons bouncing off a receipt, because copies make facts robust. Details that never got copied never become part of the public past. That isn't mystical. It's bookkeeping under a budget. Micro story. A runner bolts at the gun and swears the sound and motion were simultaneous. High speed might say his legs moved before conscious hearing. He didn't lie. His brain aligned the edits so the story stayed smooth. Here's where it gets interesting. Your personal latency rhymes with a cosmic one. Horizons fence access. The particle horizon marks the farthest light that could have reached you since the Big Bang. So far, so good. The event horizon marks what can never reach you if expansion keeps accelerating. Never, no matter what. Those are query limits. Ask inside the fence and patience pays. Ask beyond and the question returns nothing. Which turns a philosophical itch into a practical test. If the universe keeps a strict budget and your present is a stitch playback, can we catch the ledger in action? Yes, by watching what happens when the possibility of a record changes outcomes. In quantum labs, measurement isn't about eyes, it's about information. Which path tags kill interference even if nobody looks, because alternatives that leak into the environment stop talking. And if you erase which path coherently, interference reappears, but only in the right conditional slices when you sort the data. The past doesn't flip, your usable correlations do. Back to the brain for one more anchor. Libet's lag doesn't settle free will, it narrows its timing. Preparatory activity starts early. Awareness lands late. A veto window remains. That's agency under latency and cost, not outside it. It's also a mirror. Everywhere we look, from neurons to horizons, the same theme repeats. Buffers, budgets, and redundancy deciding what becomes real for us. This was the moment everything changed for our map. Your now is a negotiated truce between incoming signals and internal models, resolved just late enough to be seamless, just fast enough to guide a hand before the key is missed. Accept that, and a sharper question opens. If the present is buffered, who's paying to keep the past? The ledger answers with heat, and the edge of the sky answers with silence. The rendering budget, horizons as bandwidth caps. To see the buffer's edge, draw two lines in the sky that sound alike and act nothing alike. The particle horizon is the farthest light that could have reached us since the Big Bang, time turned into distance, about 46 billion light-years in today's stretch coordinates. The event horizon is colder. In an accelerating universe, it marks events whose signals will never reach us even if we wait forever. One is not yet. The other is never. They aren't painted domes. They're rate limits. Your light cone defines what you can physically ask and get an answer to. Beyond the particle horizon, no messages have arrived. Beyond the event horizon, no messages will. If you think in budgets, those are bandwidth caps and storage quotas. No request, no texture. No path back, no recovery. Micro story. A grad student books 2 nights on a southern telescope, points at a clean patch, stacks exposure on exposure. In the second night's final hour, a smudge clears the threshold, barely. It sits a trace farther in moving distance than last year's deepest entry. Not a wall, one more grain added to the shoreline. She writes the coordinates and laughs from fatigue. The tide rolled in one photon at a time. Why call it a rendering budget? Because physics sets hard ceilings on accessible information. Black holes taught the hint. Entropy scales with horizon area, not interior volume. In Planck units, area counts bits. If that spirit applies to any causal patch, then maximum distinctness lives on the boundary. You don't get full fidelity everywhere all at once. You get whatever can be stabilized and redundantly copied within your wedge, plus constraints for the rest. Stakes land here. Copying stabilizes facts but eats capacity. Landauer's bill says the irreversible parts, resets, merges, dump heat. The holographic whisper says the ledger tallies on surfaces. The universe can't afford an explicit microstate ledger for every region for every observer. It works like you do. Coarse grain where prediction suffices, spend bits where action depends on detail, and let unused fine print wash into thermodynamic averages. Meanwhile, horizons move. The particle horizon grows as new light arrives. Patience buys texture, faint galaxies, stretched lines, better constraints. The event horizon behaves differently. In dark energy-dominated futures, it fences off what can ever answer. Ask inside and time helps. Ask beyond and the question is misaddressed. Here's the human trap. We want edges to be cliffs, they aren't. Near the particle horizon, sources are dim, redshifted, smeared by lensing, buried in noise. Our instruments impose a practical edge well inside the physical one. Build better gear and the fade pushes out. The principle doesn't budge. Signals carry content. Content costs bandwidth. Bandwidth is capped by light speed, noise, and area-bounded entropy. Micro story. A shoreline walker kneels where wet sand darkens her shoes. The sea crawls an inch forward, leaves a scallop and one more shell. That's cosmology. No wall, just a slope and a new point added to the map. So what's rendered versus cached? Rendered are facts with redundant records inside your patch, photons from a chair bouncing into many eyes, CMB patterns measured by many detectors, spectral lines logged across observatories. Cached are correlations the global state might contain that no path through your light cone can ever retrieve. They exist in principle, not for you in practice. Objectivity lives where redundancy lives. Outside, you have priors and consistency. Thermodynamics closes the loop. Erasing a bit costs kT/ln2. Recording spends capacity. Copying multiplies cost but buys stability. If you tried to preserve every microdetail, you'd drown in heat and storage bills. Coarse graining and effective theories aren't hacks, they're survival strategies. Inflation's few parameters seeded a web, dynamics elaborated. Horizons and budgets did the rest. Horizons aren't uniform. Motion, position, and acceleration shift apparent horizons. Two observers disagree on what's inside their wedge and still query the same backend. That's relativity's geometry, not mysticism. The interface looks personal. The rules are shared. If the universe keeps a strict budget and horizons cap access, could we catch it skipping frames? People looked energy-dependent delays in gamma-ray bursts, holographic jitter in interferometers. Within current bounds, smoothness holds. That's a tell. Efficiency masquerades as grace. If there's grain underneath, symmetries and cancellations compress it below our API. Everything changes once you read horizons as bandwidth caps. History becomes whatever your patch has paid to write and can later fetch. The rest is cached elsewhere or never reachable at all. Micro story. A team simulates light near a cosmological horizon. A beacon's signal stretches into the thermal bath. Signal to noise sinks towards zero. Someone writes cached elsewhere on the whiteboard. Another adds rendered if you're closer and draws a second curve just above. Bring it back to meaning. The ledger isn't punishment, it's the operating system. The world renders the parts that many channels can carry, compresses what can be inferred, and leaves the rest implicit behind constraints. That's why independent teams recover the same sky. It's also why anomalies that won't reproduce die. One last translation. Think of every measurement as an API call. Telescopes query different bands, sites, nights. If the answer survives adversarial conditions, it's rendered. If it appears in one fragile pipeline, it's cached at best, artifact at worst. You can feel the difference. A line that reappears in another spectrograph, a transit that repeats, a shear field that matches across teams. That's redundancy doing its job. The shoreline keeps creeping. The fence keeps humming at a temperature you can barely feel. Between them runs the budget, area counts, light sinks, heat collects. The rules are blunt, the outcomes generous. You live inside a quota, and the map you can fetch is still astonishing. The energy ledger, Landauer heat and erasing history. While the shoreline creeps and the fence hums, the bill gets blunt. In 1961, Rolf Landauer nailed a simple line to the door. Erasing 1 bit costs at least kT/ln2 of heat dumped into the environment. Not computing a bit, erasing it. Charles Bennett later added an escape clause. In principle, you can compute reversibly and avoid the toll so long as you don't throw branches away. But the instant you reset memory, merge computational paths, or overwrite a register, the second law collects. Information is physical and bookkeeping burns. Stakes land fast. If forgetting has a heat signature, Stable memory requires energy, storage, and time. In a universe with horizon-bounded entropy, you can't keep everything explicit. Something gives. The facts that survive are the ones paid for with redundancy, the many paths that copy a pattern into photons, phonons, spins, and logs. The rest compress into regularities you can predict without tracking every microstate. Objectivity is a budget line. Microstory. In a quiet lab, a team builds a 1-bit memory. Particles in a double well, left is, right is 1, coupled to a thermal bath. They perform a reset to 0 regardless of input, instrumented with a sensitive bolometer. On good days, the heat pulse hugs KTLN2, tiny but there. Someone tapes a note to the rig, to forget we sweat. Translate that to cosmic terms. Every time alternatives stop interfering because information leaks into an environment, decoherence, you've effectively allocated bits to classical history within a wedge. Those bits live in redundant fragments of the environment, scattered photons, vibrating lattices, correlated molecules. Copying stabilizes facts, but redundancy multiplies cost. You spend capacity so many observers can fetch the same answer. That's the physics behind the chair is there. Quantum Darwinism gives the rule teeth. Watchsites showed that pointer states, robust variables like position, get copied into many environmental fragments. Multiple observers can read different fragments and agree without touching the system. Consensus isn't magic, it's replication. And replication consumes the ledger. The environment becomes a million reporters filing the same story, while delicate phase relations fade into inaccessible correlations. Brains rhyme with this economy. About 20 watts for everything you are. Predictive coding discards expected input and spikes for surprise. Synapses consolidate gist, not tape. Erase a memory, you pay in heat. Keep one, you pay in maintenance. Minds are thermodynamically thrifty because they have to be. The cosmos plays the same game at scale. Write sparse instructions that go far, let dynamics elaborate, and avoid tracking the impossible. Holography whispers the ceiling. Black hole thermodynamics says maximum entropy in a region scales with area, not volume. In Planck units, the bit count sits on the boundary. Treat that as guidance beyond black holes. Boundaries bookie, volumes comply. You don't get a global high-resolution archive. You get boundary-encoded constraints and interior behavior reconstructed when queries are possible. If you try to pack more distinct records into your patch than the area allows, physics pushes back by thermalizing, by collapsing, by blurring distinctions until redundancy eats uniqueness. There's a twist you can't ignore. Landauer's cost can be paid in currencies other than heat. Generalized results allow trade-offs, exporting entropy into other conserved quantities like angular momentum in exotic setups. But you don't escape the toll, you move it. The second law still tallies. That subtlety matters because it keeps our claims honest. The bill can shift platforms, but it never disappears. Microstory. A simulation team building a global weather model hits a wall. They can't resolve every eddy. They invent subgrid physics, statistical closures fit to data. The model runs faster and matches satellites better than a brute force monster that blew its cache. Someone writes on the board, spend bits where outcomes care. Now combine the lab receipt with the sky's quotas. The Gibbons Hawking temperature gives your patch a faint bath and an entropy cap. That puts a hard upper bound on distinct states your wedge can stabilize. Records that matter are the ones copied broadly. Everything else dissolves into averages. Try to hoard every microdetail and you'll either cook the ledger with heat or get your distinctions washed out by noise. Coarse graining isn't laziness, it's survival under law. This reframes history. The past you can fetch is the subset that earned redundancy inside your horizon. Documents, rocks, photons, synchronized memories. The rest. Implicit constraints in a global state you can't access, or local microfacts that never crossed into public channels before decohering into entropy. From your vantage, that's erasure. Globally, unitarity may store correlations you'll never reach. Locally, the tape is gone. And that sets the tripwire. The universe runs efficiently until you force it to answer questions it didn't budget for. In quantum labs, those questions are precise. Ask which path and you kill interference by creating records. Erase the record coherently and fringes reappear, but only in conditional subsets keyed by what you kept. No retrocausality, no magic, just control of information flow. What changes is not the past, but which correlations remain usable. Micro story. Past midnight, a student toggles an eraser mirror. The raw screen looks like mush either way. Gate the counts by the partner detector and ripples pop in one slice, flatten in another. She whispers, it waits for context. Her advisor taps the entropy chart. It waits for what we paid to keep. The ledger is blunt and merciful. Forgetting warms the room. Copying buys common ground. Boundaries count bits. Light meters access. Horizons cap distinctness. Inside those constraints, meaning stabilizes as pattern, not as tape. The next scene shows what happens when questions rewrite access, not the past. Quantum choice. When questions rewrite what's kept. Down in the dim room with the humming racks, the experiment looks child simple. Single photons head toward a plate with two slits. With no extra hardware, the counts on a distant screen slowly build bright, dark, bright interference, each photon arriving like a dot, the ensemble sketching a wave. Add tiny which path tags, polarizers, weak scatters, atoms that flip states, and the stripes vanish. Two smeared mounds appear as if marbles chose doors. The only difference is whether which path information exists in principle, not whether a human stares. Whether a recoverable record could be made. Stakes first. If the mere possibility of a record kills interference, then what's real depends on information flow, not attention. That's decoherence. When alternatives leak into the environment, air, photons, internal degrees of freedom, their relative phase becomes locally inaccessible. The global state still evolves unitarily, but branches stop talking in your wedge. You get facts in place of fringes because records formed. Here, S where timing gets teeth. In the delayed choice quantum eraser, you let a photon pass the slits, then down the line split it into entangled partners in a nonlinear crystal. One partner, call it signal, heads straight to the big screen. The other, idler, meanders through an adjustable maze. Some routes preserve which path tags, others recombine them to erase path information coherently. Only after signal has already hit do you decide which maze path idler takes. The raw signal screen never shows clean stripes either way. But when you later sort those signal hits into subsets keyed by idler's outcomes, a surprise lands. The subsets paired with erased which path display interference. The subsets paired with preserved which path do not. No paradox survives careful bookkeeping. There's no backward in time influence, no message to the past. The joint state carries correlations from the moment the pair is created. Your later choice selects which correlations you can extract by conditioning on idler's result. The pattern appears only in post-selected slices that were always encoded in the entangled state. The unconditional distribution stays stripe-free. You didn't change the past. You revised which history class is usable. Micro story. A student leans over a coincidence counter at 2 a.m., toggling a mirror that sends idlers into the eraser arm. The big screen looks like noise either way. She gates the counts by partner detectors. Ripples pop in one conditional plot, flatten in another. It waits for the question we can ask, she whispers. The advisor nods. It waits for context. Now pull back from lab myth. Observation in quantum theory isn't a gaze. It's entangling with enough degrees of freedom that reversal is impractical. Photodiodes click. Stray fields couple. Warm instruments soak up phase. In Copenhagen-flavored talk, you update a state when you measure. In many worlds, no collapse, just branching that isolates alternatives. In all empirically equivalent accounts, acquiring which path trades interference for records. Erasing which path by coherent recombination restores access to phase, but only within the right conditional partitions. That's the rule. Context decides usability. Here's the ledger hook. Recording which path consumes capacity. Landauer's bill for irreversibility. Redundancy stabilizes facts across the environment but multiplies cost. Erasing isn't free either. To recombine histories, you must prevent the environment from grabbing tags. That's why fringes flourish in cold, isolated gear and die in messy rooms. The universe avoids tracking the impossible by letting unused branches decohere into inaccessibility. It budgets reality by stabilizing only what gets copied widely. Scale the logic. You won't tag the paths of galaxies, but the same mechanism picks classical stories at macro scales. Decoherence without minds. Environment-induced superselection selects pointer variables, dust positions, currents in loops, collective modes in a plasma. Quantum Darwinism adds the kicker. Objectivity emerges when many fragments redundantly encode the same pointer information. A chair leaks its location into billions of photons. Dozens of observers can sample disjoint fragments and agree. No redundancy, no objectivity. No objectivity, no recoverable past slice for you. This invites a dangerous sentence. The future rewrites the past. Don't say it. In delayed choice, the joint state evolves smoothly all along. You're sorting earlier events by later, entangled records to reveal patterns that were always present in correlations. The rewrite is a reclassification. You decide which conditional world you'll treat as the story by choosing which registers to keep. The past doesn't flip, your compression scheme does. Micro story. A visiting philosopher asks if the signal hit wasn't really a fringe until the sorter decided. The postdoc shrugs. The unconditional pattern never had fringes. The conditional subsets did once we grouped by idler outcomes. We changed counting, not history. Bring timing back to agency. Libet's veto window sits at the edge of action. Here, the eraser's window sits at the edge of usability. In both, the world offers options early. Context decides late which ones become facts you can exploit. Preparatory neural ramps start. You may still cancel. Path alternatives exist in amplitudes. You may still erase tags and recover interference in the right slices. Agency under latency and cost rhymes across scales. And there's a quiet mercy. The same rule that makes fringes fragile makes facts durable. Once which path leaks broadly, the environment acts as an archival committee. Many copies, same pointer state, stable for everyone who can query the room. That's expensive, but it's why your world looks crisp. Where copying didn't happen, usable alternatives fade, locally erased by decoherence, globally stored as correlations beyond your API. So the moral of the eraser isn't retrocausality, it's scope. What counts as what happened is what stable correlations you can fetch, given the records you kept and the channels you control. Questions rewrite what's kept because questions decide which slices of the joint story become public facts. The ledger pays for macro decoherence, not for every sky that picks a story. Zoom out. The same rule that kills fringes at the slit writes the sky we live under. In the early universe, quantum fields jittered. Inflation stretched those jitters to cosmic scales, then let them freeze when wavelengths outran the horizon. But freezing wasn't enough. Those ripples had to stop behaving like delicate phases and start acting like classical differences. The environment did it. Here, environment doesn't mean a lab bench. It means a bath of photons, neutrinos, gravitons, and the self-gravity of the fluctuations themselves. As modes re-entered the horizon, they coupled to that bath. Phase information bled into countless degrees of freedom. Decoherence selected a pointer basis for the cosmos. Curvature perturbations with definite phases relative to the photon, baryon fluid. Alternatives that could have interfered became classical initial conditions, because the universe wouldn't stop measuring. You can still hear that choice in the microwave background's music. The acoustic peaks are fossil drumbeats from a ringing plasma before atoms formed. Their near Gaussian statistics with a slight tilt are ruthless compression, simple inputs, huge reach. Small non-Gaussianities sit within tight bounds. That's the environment telling you it crushed fragile coherence and left a clean stochastic field. Maps aren't art, they're receipts. Micro story. In a dark control room, the final Planck spectrum appears. Someone circles NS approximately 0.965 on a whiteboard. Tiny tilt, giant consequence. They don't cheer, they exhale. The sky picked a story and stuck to it. Quantum Darwinism scales here. Facts persist when many copies exist. On cosmic canvases, those copies are everywhere. Photons from the last scattering surface carry the same pattern in every direction. Later, starlight, dust emission, and lensing rewrite the web again and again. Observers separated by billions of light years can sample different fragments and agree on the same large-scale structure without touching it. Objectivity is redundancy at scale. Decoherence times at macro scales are brutal. A galactic gas cloud bathed in backgrounds, shocks, and tides loses phase faster than you can name it. That's why you don't see interference fringes in galaxy counts. Positions, velocities, and densities look crisp, while quantum phases don't matter to telescopes. The environment wrote the dictionary and publishes editions continuously. Bring back the ledger. Making those facts public eats budget. Every redundant photon that encodes a density contrast spends capacity, but the payoff is stability. When many channels carry the same pointer information, no single failure erases the past. That's why independent surveys recover the same peaks and wiggles. It's also why one-off pipeline anomaly dies under cross-checks. Micro story. A small instrument on the Atacama Plateau chases B-mode curls in CMB polarization. Dust fights back. Systematics bite. The team tightens upper limits. Nothing flashy happens. But each bound narrows the pen that wrote the initial conditions, and each null says, simpler than you feared, richer than you hoped. Meanwhile, inflation reads like the first compressor. A handful of parameters, amplitude, tilt, baryon fraction, dark matter density, predict correlation functions across the whole sky. You don't get a frame-by-frame archive of the primordial state. You get sparse instructions broadcast everywhere and elaborated by gravity. Boundaries tally, volumes comply. Holography's whisper keeps time, area counts bits, horizons gate access. Here, S where the eraser lesson reappears without mysticism. The sky doesn't rewrite the past. It chooses which correlations become publicly usable. Modes that decohered into pointer variables and got copied widely are what happened for us. Delicate phases that never gained redundancy stayed private amplitudes and lost power to interfere. Globally, unitarity stores correlations you can't reach. Locally, those alternatives are gone for all practical purposes. That's why anomalies demand discipline. The CMB cold spot, a rare statistical tail, a line of sight under density imprint, or a hint of pre-inflation features, the jury stays careful. Define tests before you look, blind analyses, or you'll be fooled by your own curiosity. Voids the size of Boötes. Rare, not impossible. 1,000 realizations of the seed field give a few. Emptiness is under rendering. It's compression where there's nothing to correlate. Micro story. A grad student merges lensing catalogs, reprocesses flats, and watches a shear map sharpen. Last month's alignment dissolves into calibration artifact. She posts the pipeline and the fix. The comment that matters most reads, reproduced. Scale the moral to galaxies. Bars persist for billions of years not because quantum mysteries bless them, but because macroscopic variables, mass distributions, angular momentum, broadcast themselves relentlessly. A qubit dies without shielding. A barred spiral survives under floodlights. Same rule, different regime. Stability is broadcast, not bestowed. And there's a human echo. Instruments are redundancy engines. Independent teams, bands, and baselines aren't bureaucracy. They're how cosmic facts become rendered. A line that repeats across spectrographs earns reality. A transient that never returns slides into statistical air. Objectivity lives where copies live. So when you look up, you're not viewing a fully rendered film. You're querying a database built by decoherence and duplication under finite budgets. The miracle is that it's enough. With area-counted bits on horizons, with light's brutal sync rate, with heat as the audit trail, The cosmos stabilizes a story we can share. The sky picked a basis, broadcast it everywhere, and left just enough slack for new questions, if you can afford the records. The great erasure. What doesn't get copied fades. If redundancy makes facts public, the inverse is blunt. What doesn't get copied fades. Not by decree, by dynamics. Branches that never broadcast lose power to interfere. Details that never spread never join anyone's recoverable past. Globally, amplitudes may persist in correlations. Locally, access evaporates. From your wedge, that's erasure. Stakes first. Objectivity is a function of accessible redundancy. A footprint in wet sand exists for everyone on the beach because photons, air, and later phones proliferate the imprint. A single molecule nudged in the same patch carries no public story. The universe doesn't track both with equal zeal. It spends bits where many channels can carry them. Everything else compresses into averages you can predict without playback. Micro story. A technician leaves a chair in a dark, cold, evacuated chamber and shuts the door. No stray photons, no air, no dust. Overnight, its position leaks almost nowhere. Inside that isolation, quantum fuzz can, in principle, grow. Place the same chair in a lit, messy room and trillions of photons tattle on it every second. In the morning, everyone points to the same spot. Reality isn't assigned by eyes. It's stabilized by leaks. Horizon quotas sharpen the edge. Inside a finite causal patch with area-bounded entropy, you can't preserve unbounded distinctness. The system selects what to keep by building many weak, overlapping records, photons, phonons, pressure waves, that repeat the same macro facts. Patterns with no broadcast pathway never accumulate copies. They remain private amplitudes destined to decohere into other people's noise. No redundancy, no objectivity. No objectivity, no history you can fetch. This is where erasure earns its name without violating unitarity. Decoherence doesn't delete amplitudes from the universal state. It dissolves local access by dispersing phase information into environmental degrees of freedom. Landauer wrote the receipt. To forget is to heat. In practice, warm, messy environments erase by copying junk. The micro-correlations smear into entropy you can't reassemble. The world keeps the sums and drops the micro-summands. Add the interface. Cosmological horizons act like storage quotas and filters. Facts redundantly written inside your wedge remain fetchable. Facts that never got broadcast within your light cone never become part of your recoverable past. Out beyond the event horizon, correlations may live on, encoded in degrees of freedom you'll never query. Locally, that's indistinguishable from deletion. Accounting language helps, cached elsewhere, not on your balance sheet. Micro story. A radio astronomer chases a rumored transient. The array is clean, baselines are long. A blip appears, then drowns under ionospheric junk. Hours later, a second facility sees nothing. The event either happened or didn't. Either way, records didn't proliferate. The log gets tagged unconfirmed and slides into statistical air. Here's the practical split. Rendered versus cached. Rendered means stabilized by multiple, independent encodings accessible within your patch, photons, logs, rocks, redundant instruments. Cached means correlations exist globally but remain outside your API now or forever. You can infer, constrain, cross-check with priors, but you can't retrieve missing frames. Compression rules here. Coarse graining keeps equations predictive while discarding internal detail. Effective theories tell you what matters at your scale. The rest lives as constraints, not pixels. Redundancy isn't free, it eats index. Quantum Darwinism says that's the point. Many fragments carry the same pointer information, making facts shareable, but each copy spends capacity you could have used elsewhere. You can't redundantly encode everything. The universe triages. Macroscopic, behavior-relevant variables get broadcast. Microscopic, dynamically irrelevant specifics get absorbed. That triage is the great erasure at work. Black holes turn the volume up. Throw a diary in and you'd swear it's gone. Modern tools say otherwise. The page curve bends. Information isn't destroyed, it's scrambled into Hawking radiation encoded on quantum extremal surfaces in ways a patient, impossible decoder could, in principle, untangle. Globally, no loss. Locally, every realistic observer is out of luck. From any human wedge that's indistinguishable from deletion. Erasure for us, recoding for the ledger. Micro story. Past midnight, a theorist sketches a horizon and an island. Writes bits never die, they relocate. Then adds, locally they do. Both stay on the board because both are true depending on who asks. If that sounds austere, it's also merciful. A world that didn't erase would bury us in trivia. By letting unused detail fade, the universe keeps causal channels clear. Meaning survives as stabilized pattern, promises kept in matter and light, data archived across sites, signals redundantly recorded. That's not cynicism. It's design under constraint. Translate to habits. Institutions are redundancy engines. Instruments are query amplifiers. Public ledgers, mirrored archives, open pipelines. They turn private amplitudes into rendered facts. A single clip is fragile. 3 independent channels build reality. You feel the difference when a spectral line reappears in another spectrograph, when a transit repeats on schedule, when a lensing shear matches across teams. Micro story. A small observatory spots a startling flare. Instead of a viral post, they ping 2 other arrays, post raw frames, share the reduction script. 90 minutes later, confirmations land. When they publish, the signal is already rendered. Trust scales with copies, not drama. The rule bites both ways. Hoarding fragile details wastes budget. Overcopying noise pollutes channels. The craft is placement. Choose which variables get broadcast at what fidelity across which paths. Error-correcting codes add the right redundancy to beat expected noise. Good archives do the same. Backup where failure is likely. Compress where stability is high. Sunset copies that outlive use. And remember the fence. Some caches aren't just inconvenient, they're outside your horizon forever. The right stance is humility. Build redundancy where you can reach. Accept uncertainty where you can't. Read nulls as answers. In a finite, rate-limited world, smoothness is a feature. Constraints beat myths because they keep paying rent. So the great erasure isn't malice, it's budget. What doesn't get copied fades for you. The ledger keeps clean books you can't read. Your wedge keeps a public record you can. Live there. Write what matters many times. Let the rest wash into averages. The universe will thank you with facts you can fetch. The black hole accountant, the page curve and recovery. Walk to the edge and toss a diary in. The horizon swallows it without a ripple. Stephen Hawking's early calculation says the hole glows faintly, almost perfectly thermal, and the radiation doesn't carry your handwriting. Let the hole evaporate and you're left with featureless heat. That looks like deletion, not compression, a break with unitary quantum mechanics. If information can vanish, the ledger we've been trusting is crooked. Physicists drew the paradox as a line. Put time on the x-axis, the fine-grained entropy of the outgoing radiation on the y-axis. Don Page argued that if evaporation is unitary, that curve should rise at first. Early photons entangle with what's left, peak around halfway, then fall as later quanta carry back the missing correlations. That's the Page curve. Hawking's semi-classical story gave a different graph. Entropy climbs monotonically to the end. The mismatch sharpened the blade. What changed wasn't a flourish. It was the tools. Gravity learned to count quantumly, using replica trick path integrals and allowing new gravitational saddles, wormholes in the math. Researchers computed the radiation's entropy while keeping track of entanglement with interior modes. A new ingredient appeared after the halfway mark, the island. When you compute fine-grained entropy of the radiation, parts of what you'd call the interior must be included in the radiation's entanglement wedge. The line bends. Entropy rises early, turns at the page time, and drops towards zero as the whole finishes evaporating. The accountant's stamp is back. Books balanced, no bits lost. Micro story. A young theorist paces a quiet hallway at midnight, highlighter in hand, tracing a diagram. radiation region here, an extremal surface there, a dashed loop marking the island just inside the horizon. The calculation says the outward stream encodes interior data after the page time. They grin, not because the mystery evaporates, but because the curve finally turns when it must. Stakes bite harder now. If evaporation is unitary, where practically is the diary? A new tension lit up the room, the firewall. Past the page time, late Hawking quanta should be highly entangled with early radiation if unitarity holds. Semi-classical smooth horizons say the same quanta are also maximally entangled with partners just behind the horizon. Entanglement monogamy forbids both. So pick, keep unitarity and torch the horizon's smoothness, or keep the smooth ride and break quantum mechanics. Neither option felt right. People hunted for a door that didn't burn. One route leaned on quantum error correction in holography. Bulk operators, including ones behind horizons, can be reconstructed from different boundary regions depending on the global state. No cloning occurs. Redundancy is structured. Another route invoked complementarity. No single observer can verify both stories. The infaller sees a smooth horizon with interior partners. The patient, impossible decoder far away can, in principle, recover the diary from radiation. No contradiction appears within any one causal patch. Soft hair added texture. Subtle asymptotic charges on horizons expand bookkeeping at the edge. Gravitational dressing and back reaction blur naive splits between inside and outside. Surfaces tally. Volumes comply. There's a practical sting in the fairy tale. Hayden and Preskill modeled an old hole as a mirror. Throw a diary in after the page time. Wait a scrambling delay. Order m log m in Planck units. Then, in principle, information begins to leak out at the Hawking rate. With fantastical quantum control and a reference copy, you could decode it. In practice, decoding is astronomically hard. The universe is unitary but ungenerous with shortcuts. The ledger keeps perfect archives in formats mortals can't read. Micro story. In a coffee-stained seminar room, someone sketches a circuit that decodes Hawking radiation if you possess an entangled reference of the diary. Laughter rolls. The point lands anyway. Recovery is a principle, not a button. Fold this back into our rendering metaphor without cheating. Black holes don't delete frames. They shred and scramble, then reissue content across channels that sit beyond practical fetch. The page curve's turn isn't retrocausality. It's a receipt that global evolution stays clean even when local access screams loss. From your wedge, the diary is gone. In the ledger, it moved. Here's the emotional cut. We don't live on the accountant's side. Horizons are interfaces. A Gibbons Hawking temperature hums, a faint bath. Entropy scales with area. The maximum distinctness of your patch is finite. Throw enough detail at the boundary and it returns as noise, not notes. That asymmetry, global conservation, local oblivion, is the heart of why time feels like erasure while physics insists it is. Everything black holes taught turns into a rule. Boundaries encode. Interiors are reconstructed by access and context. Redundancy stabilizes facts. Scrambling hides them. If no detail is deleted globally, why does it feel gone locally? Because you're rate limited. The interface defines which queries return payloads and which time out forever. The next move is to treat every horizon that way, personal APIs with budgets, and ask what's rendered and what's merely cached, not just at the edge of a hole, but at the edge of your world. The interface rule, what's rendered versus what's cached. Stand at your edge and ask a simple thing. What answers can come back? The reply depends on the interface, your horizon, and on who's asking. In a universe with gravity and expansion, horizons aren't brick walls. They're APIs. They define which queries return payloads, which stall forever, and how much detail any answer can carry. Change your motion, your position, your acceleration, and the menu shifts. 3 surfaces matter for our patch. The particle horizon lists everything that has reached us so far. The event horizon lists what can ever reach us if acceleration persists. The apparent horizon is immediate, a locally defined knife edge where outward light just fails to get farther away. They sound similar, they serve different roles. Two people on different world lines consult the same backend and see different dashboards. That's not mysticism, that's geometry. Thermodynamics watermarks the interface. A de Sitter, like Patch with dark energy, has a Gibbons, Hawking temperature set by the horizon scale and an entropy proportional to horizon area. That's the boundary ledger again. For any observer, the number of distinct states their wedge can distinguish is finite. The interface hums with a faint thermal bath, too cold to feel, loud enough to announce that edges are alive. Translate this to rendering. Inside your wedge, facts stabilize when records are copied across accessible channels. Photons scatter off a table, molecules carry pressure waves, detectors dump bits that survive resets. Many independent queries return the same answer. That's rendered. Past your interface, the story changes. Correlations exist in the global state, but you can't pull them through your API. That's cached elsewhere, present in principle, absent for you. Micro-story. Two observers drift in a dark energy-dominated era. One coasts inertially, the other fires engines and holds constant acceleration. Their apparent horizons sit at different radii. The accelerated traveler sees a warmer bath, an unreal whisper from the interface. They point identical instruments at the same cluster. One catalog returns thousands of members, the other trims at the faint edge. Same backend, different rate limits. Objectivity becomes a function of accessible redundancy. Many copies, many paths, same answer. One fragile clip, one lossy channel, no objectivity. That's the selection rule. The universe stabilizes variables lots of detectors can read without disturbance. Positions, frequencies, fluxes, shear patterns. Exotic phase relations that need global coherence don't meet the interface. They remain cached behind horizons or drowned in local baths. Rate limits bite. Finite horizon entropy means finite recoverable detail. Try to pack more independent records into your wedge than the area allows, and physics pushes back. By thermalizing distinctions, by gravitational collapse, by decohering until redundancy eats uniqueness. You can't beat the interface with clever encoding forever. Quantum error correction thrives within a finite code space. The code space is bounded by your edge. Hear the interface from inside your instruments. Every measurement is an API call. Telescopes query in multiple bands, epochs, and sites. If a feature survives adversarial conditions, it's rendered. If it appears only in one fragile pipeline, it's cached at best, hallucinated at worst. You can feel the difference. A line reappears at higher resolution. A transit repeats on schedule. A lensing field matches across teams. Redundancy confers reality. Holography hides in plain view here. Boundaries encode bulk behavior. Entropy scales with area, not volume. In toy dualities, interior operators are reconstructed from boundary data inside an entanglement wedge. In our patch, treat that as guidance. What counts as inside depends on which boundary regions your interface can clasp coherently. Different observers reconstruct different interior slices without contradiction, because no one can call every endpoint at once. Micro-story. A team simulates light propagation near a cosmological horizon and watches a beacon smear into the thermal bath. Signal to noise sinks asymptotically towards zero. The last bits never arrive. Someone writes cached elsewhere on the whiteboard and draws a dashed line. A colleague adds rendered if you're closer and sketches a second curve just above. Stakes sneak in. If horizons are interfaces, reality isn't a monolithic render farm. It's a distributed system with budgets. Facts win when they're encoded redundantly within rate limits. Ambiguities linger when they can't be. There is no global now to fetch. There are mosaics assembled at light speed and bounded by area laws, bathed by a temperature you rarely feel. This reframes glitches. A perfect compression looks like smoothness, not dropped frames. Null dispersion across gamma-ray energies says the interface respects Lorentz symmetry painfully well. Interferometers that fail to find holographic jitter set bounds on how noisy the edge can be. The absence of flicker is an answer. If there's grain underneath, symmetries compress it below your API's resolution. Bring it to human stakes. Memory is an interface. What you write to paper, post to open archives, and repeat across minds becomes rendered history in your wedge. What you keep private in a single channel stays cached until it fades. Institutions are redundancy engines. Standards and instruments widen the API. One last rule of thumb. Map your interface. Keep a mental list of what your patch can stabilize, repeating transits, reproducible spectra, cross-team shear, and what it can't, single-frame anomalies, one-off bursts with no corroboration, claims beyond causal reach. Spend bandwidth on the first, humility on the second. The interface we want reward you and the physics we can fetch and keep. If horizons are interfaces and objectivity is redundancy, the next instinct is obvious. Hunt for the engine's mistakes. We tried. The early James Webb results looked like a crack, too big, too soon. Photometric fits hinted at hefty galaxies a few 100 million years after the Big Bang. For a week, it felt like the code blinked. Then spectra arrived. Some candidates slid down in redshift once emission lines were nailed. Others stayed high but shrank in inferred mass when models handled dust, line boosting, and lensing magnification better. Selection favored the luminous tail we can actually see. The picture got disciplined, not dull. Micro story. A team bets a bottle that their brightest speck will collapse to Z5 once they get a clean line. The spectrum pins the break high. Mass ticks down, distance holds. They pay up and add a subgrid term for metal-poor starbursts. The code runs better the next night. Voids got the same treatment. You swing the camera to the Boötes void and your first thought is missing texture. But run enough universes from inflation's seed field and gravity's growth, and a few giant hollows pop up. Rare isn't impossible. The human eye wants uniform paint. The cosmic web prefers contrast. Emptiness isn't an error. It's compression where there's nothing to correlate. Then came the cosmic microwave background's cold spot, a big, deep dip a few degrees wide. Surveys found an extended underdensity along the line of sight, but probably not enough to do the whole job via the integrated Sachs-Wolf effect. Is it a statistical tale, a modest anomaly, a relic from pre-inflation physics? The honest answer is caution. Define tests before looking or you inflate drama. Blind analyses keep you from fooling yourself. Either way, the sky didn't fail. It left a question with a cost. Pixel hunts promised sharper thrills. If spacetime had grain, high-energy photons from distant gamma-ray bursts might arrive splayed by energy, dispersion sneaking in like cheap glass. Observatories stacked light curves chasing lags. Within tight bounds, photons marched in step across ridiculous energies and distances. Interferometers listened for holographic jitter, correlated positional noise at Planck whispers. Clever setups set upper limits, no confirmed wiggle. Smoothness held. That's not a letdown. It's information. If there's discretization underneath, it respects Lorentz symmetry painfully well and hides behind extraordinary compression. Micro story. A preprint posts claiming energy-dependent delays. 2 months later, the authors fold in instrument response and source intrinsic lags. The signal evaporates. At the next coffee line, the lead presents the null without hedging. The room nods. Constraint beats myth because it keeps paying rent. Even JWST's early fuss turned from crisis into physics. A few galaxies stayed massive and compact at high redshift. Simulators pushed star formation efficiency up in dense, metal-poor clumps, let massive stars front-load light, tweaked feedback so gas converted before winds kicked hard. Lensing catalogs got better, size biases softened. Some objects remain interesting. None overthrow the scaffolding nailed by acoustic peaks, baryon acoustic oscillations, lensing, and primordial abundances. You don't bulldoze a house because one window fogged. You clean the pane, then check the frame. Voids and cold patches became laboratories. Galaxies in emptiness evolve quieter, fewer interactions, cleaner inflows. Measurements their test feedback recipes without the noise of crowded nodes. The cold spot, stubborn and lonely, forces rigor. If it's a fluke, the distribution tails must allow it. If it's relic physics, it will echo in polarization or large-scale alignments. If it's late-time structure, deeper surveys must stack underdensities to close the gap. Each path is falsifiable. Each path costs bandwidth. Here's the trap we keep dodging. A rate-limited world looks like perfect compression, not like obvious dropped frames. The absence of dispersion is a statement. Null holographic noise is a statement. Near Gaussian CMB statistics with small tilt are receipts. A spectrum that's too clean isn't evidence of faking. It's the signature of a sparse instruction set stretched far. Micro story. A grad student merges two catalogs, reprocesses flats, and watches a lensing shear map sharpen. Last month's anomaly dissolves into a calibration artifact. She posts the updated pipeline public. Comments praise the fix more than the initial buzz. That's how trust scales in a redundancy game. So where's the line between myth and mechanism? Right where budgets and interfaces say it is. If a claim rests on one fragile channel, treat it as cached at best. If it reproduces across instruments, methods, and teams, independent encodings inside our wedge, it graduates to rendered. Constraints aren't buzzkill. They're how a finite entropy universe says yes. The story gets richer as myths fall away because the remaining patterns have earned their bandwidth. The stakes are practical. Train on real constraints and you stop chasing fireworks. You start reading ledgers, design instruments to cross-confirm, build pipelines that catch your illusions, form collaborations that multiply copies, learn to love nulls. In a world that budgets bits by area and meters answers at light speed, smoothness is a feature, not a conspiracy. We didn't catch the engine skipping frames. We caught it being efficient. Which leaves a smarter move. Stop asking for glitches. Ask how efficiency becomes law. Coarse graining, effective theories, boundary data reconstructing bulk behavior, inflation as the first compressor. Those aren't metaphors. They're the operating system. And if minimal description runs the show, then time itself might be what compression feels like from the inside. Efficiency as law, why minimal wins. If glitches weren't the story, efficiency was. The cosmos keeps rewarding the same move. Throw away what you don't need, keep what controls outcomes, and let the rest average out. Not as a shortcut, as law under budgets. Start with coarse graining. Nobody models a hurricane by tracking every molecule. You keep pressure, temperature, vorticity, and a closure for turbulence. The map is smaller than the territory, yet it predicts the only things you can test: storm tracks, wind fields, landfall. Effective theories formalize that instinct. At low energies, a few relevant operators run the show, heavy details decouple. The renormalization group explains why. Flows drive diverse micro-worlds toward the same fixed points with sparse descriptions. Universality is compression with receipts. Micro story. A mission sim team starts with a full plasma code and stalls. They switch to magnetohydrodynamics with subgrid closures fit to data. The model shrinks by orders of magnitude and matches telemetry better. Someone writes on the board, fewer knobs, cleaner predictions, and underlines it twice. Thermodynamics backs the move. Landauer says erasure costs at least KT-ln2. Bennett says you can avoid the toll only by keeping every branch, reversible computing in principle. Nature splits the difference. When it must stabilize facts, it pays the bill. When it can, it computes by symmetries, conservation laws, and reversible dynamics, exporting as little entropy as possible. Minimal state descriptions waste fewer bits across horizons. When you must forget, merge histories, reset memories, broadcast facts, the heat goes somewhere. Coarse graining marks the boundary between what you keep and what the bath absorbs. Holography sharpens the edge. Boundaries encode bulk. Entropy scales with area, not volume. In toy dualities, a gravitational interior is reconstructed from a leaner boundary theory. Our patch isn't ADS, but the guidance is loud. Store minimally on edges. Reconstruct what you ask only when you can. Area-counted bits demand spare instruction sets stretched far. Inflation looks like the first compressor. A tiny causal patch gets stretched, wrinkles flatten, clutter dies, quantum jitters promote to seeds. A handful of numbers, amplitude, tilt, baryon fraction, dark matter density, predict correlation functions across the whole sky. The CMB's near Gaussianity reads like a checksum. Simple spectrum, slight tilt, tight non-Gaussian bounds. Sparse input, vast structure. Micro-story. In a cramped office, a cosmologist taps NS approximately 0.965. A hair under 1, she says. The hill wasn't flat. Her student grins. 1 decimal travels from a map to a mechanism and back. Minimal wins elsewhere. The standard model is audaciously short and still nails cross-sections across energies. Gravity comes from an action with the fewest derivatives respecting diffeomorphism invariance. In condensed matter, diverse systems share critical exponents. Everywhere, the winning description is the one with the least baggage that still closes under tests. Fewer bits, more reach. Bring it to instruments. The best detectors aren't maximalists, they're matched filters. You design for the signal you can test, not every possibility. LIGO listens in a narrow window with exquisitely tuned optics and software that rejects what it can't certify. The square kilometer array will map a single line, the 21 centimeter whisper, and let statistics speak. The trick keeps paying. Compress raw streams into sufficient statistics that travel well between teams. Brains already play this game. About 20 watts. Predictive coding discards expected input and spikes for surprise. Memory consolidates just because verbatim costs too much heat and space. You experience continuity because your decoder fills gaps with priors until receipts arrive. Minimal wins because it's the only way to survive on a diet that thin. Micro-story. A guidance team ships flight code that's 1/10 the size of the training sim. The in-flight estimator carries biases and noise terms tuned to telemetry, not a full plasma model. The craft threads a corridor on time. Later, the post-flight report reads, "Smaller flew, bigger trained it." Now fold efficiency into time. If the universe runs on sparse instructions and finite ledgers, then becoming is what compression feels like from the inside. The present is the latest decode of patterns redundantly written. The past you can fetch is the subset that made it into public channels. Prediction beats playback because prediction uses short rules. Playback needs tapes you rarely have. The arrow of time shows up where erasure happens. When alternatives merge, baths absorb fine distinctions, and copying stabilizes one branch at the cost of others. Usability. Entropy grows because minimal descriptions offload detail to the environment. This reframes beauty. Simple laws with wide domains aren't aesthetic luck. They're the necessary shape of explanations that can be rendered within horizons. Explanations that sprawl fail the budget. Theories that overfit collapse outside their training set. The ones that last are the ones that spend few bits and reproduce the most independent records. So practice the law. When you hunt causes, favor models with fewer free parameters that still clear adversarial tests. When you build instruments, design for cross-confirmation and publish pipelines. When you read anomalies, ask what subgrid you missed before you invent a glitch. Minimal isn't cutting corners, it's aligning with the operating system. Micro-story. A junior analyst replaces a 30-feature classifier with 3 hand-built ratios tied to known physics. Accuracy holds, calibration improves, interpretability jumps. The review ends with a line no one argues with. We can carry this into space. Efficiency isn't optional. It's how a finite, rate-limited universe stabilizes truth. Keep what matters. Let the rest wash into averages. Time is the feeling of those choices adding up. Time without storage. The past is a compressed file. If efficiency runs the show, then time stops looking like a river and starts looking like a codec. Your present isn't streamed. It's decoded, stitched from records your wedge can fetch and priors your brain supplies when the tape runs thin. No record, no replay. Not absence, just no access under your interface. Start local. Relational time says order lives in receipts. A footprint before a photograph, a payment before a receipt, a pulse before a log entry. The arrow isn't painted on reality. It's derived from correlations that let you align this then that. Your nervous system already plays this game. Predictive coding guesses the next frame and spikes for error. Memory keeps gist because verbatim burns heat. You feel continuity because your decoder backfills until photons, audio, or numbers arrive with proof. Zoom to spacetime. Every now is a mosaic assembled at light speed. Hands are milliseconds late, the street is microseconds behind, the moon is a second, the star is centuries. There's no global present to render in one sweep. There are light cones delimiting what can be queried and stitched. When you say before, you mean in the set of events whose records reached me in time to include them. Micro story. A mountaineer's watch dies mid-ascent. She still knows when to turn, the sun's angle, the snow's crisp, the rhythm of breath match years of training data. Later, GPS logs anchor her story. The watch didn't keep time, the world did. Retrieval is expensive. Inference is cheap. Playback needs tapes you rarely have. Prediction uses short rules. A handful of parameters propagate forward and get checked against receipts. That's why physics prefers effective theories over full microstate tracking. It's why you can fly a craft on biases and noise terms instead of a plasma universe. The universe favors prediction because it runs on sparse rules and finite ledgers. You get laws that compress, not archives that replay. Memory is physical isn't a slogan, it's policy. Records live in matter and light, in synapses and servers, in photons that bounced and kept bouncing. If a detail never made copies, it never joins the public past. Decoherence seals the deal by letting alternatives that weren't broadcast lose power to interfere. Landauer writes the receipt. Stabilization and erasure both cost. You feel the economy when an old email rescues a date, and a vanished text leaves only the shape of a conversation. Micro story. A lab resets a qubit, 0 regardless of input, and a bolometer ticks. The heat bump is tiny, around kT/ln2 per bit, but measurable. They repeat 1,000,000 times. The curve doesn't lie. Forgetting was a physical event. Horizon logic finishes the frame. Within your patch, a faint Gibbons, Hawking-Bath hums and entropy is finite. That caps distinctness. You can stabilize only so much past. The rest compresses into effective variables, spectra, correlation functions, bulk flows that travel well. Holography whispers the same rule. Boundaries in code. Interiors are reconstructed by consistency when queries are possible. Your cosmic archive is a sky, not a vault. You read it by solving inverse problems with priors you've earned. Relational time gets teeth in quantum labs. In delayed choice experiments, the past you can exploit depends on which correlations you sort later. That isn't retrocausality, it's scope. You didn't change events. You decided which slices of the joint story become usable facts by choosing which registers to keep. In quantum error correction, the location of bulk information depends on which boundary region you hold. Reconstruction is state-dependent. None of that flips history. It tells you that what happened means what stable pattern you can fetch under your interface. So what does that buy you? A way to live with finite ledgers. Stabilize what matters by copying it. Open data, mirrored archives, public commitments, designs others can build without you. Don't count on perfect tape. Build redundancy into patterns you want to persist. Accept uncertainty where records are thin. Invest in channels that will be thick. Micro story. A survey posts visibilities, calibration scripts, and final maps. Months later, a grad student on another continent reruns the pipeline, fixes a bias, and recovers the same line. The object becomes real by replication. The past is what the authors say happened. It's what decoders can independently retrieve. Here's the quiet term. Time's arrow isn't glued to entropy in the abstract. It's the felt consequence of compression under constraints. As alternatives merge and baths absorb fine structure, the usable past becomes simpler, more public, less reversible. Your sense of then to now is the decoder walking forward as records accumulate and erasures leave heat. So no, the universe isn't deleting your past out of spite. It's keeping you honest. It preserves the parts many channels wrote and lets unneeded detail fade. Time is what that feels like from inside a finite wedge. A continuous decode of a sparse file, stitched by light, bounded by area, stabilized by copies. Open it carefully. Don't expect frames
Agency in a finite past
to store what you make redundant. If the past you can fetch is the past your world paid to write, then agency isn't a mood. It's a storage strategy. You don't control the ledger's quotas or light's sync rate. You do influence which patterns get redundantly encoded inside your wedge. Meaning isn't what you think, it's what you stabilize. Start small. A promise spoken once is fragile. A promise written, witnessed, timestamped, and mirrored hardens into a public fact. Institutions exist for this reason. They're redundancy engines, charters, ledgers, archives, protocols that copy intentions into matter and light so they survive memory's heat bill. You don't beat entropy with willpower. You outright it. Micro story. She builds an array on a dry plateau. Aluminum ribs, cryo receivers, a line of dishes that will listen for years. She knows the decisive measurement will arrive after she's gone. She still fights for open telemetry, mirrored servers, and field logs anyone can read. A decade later, a student she'll never meet reprocesses the visibilities and pulls a line from the noise. Her name isn't first, but the pattern she wanted persists. That's agency under constraint. Design with horizons in mind. Spend on reachable systems, channels inside your causal patch where copies can propagate and be cross-checked. That's climate sensors maintained across nations, not a campaign to sway a star you can't signal. That's data released in parsable formats, not tucked behind a proprietary tool. That's instruments that generate independent channels, different bands, baselines, and sites, so facts graduate from seen once to rendered. There's a seductive error here. You can drown your world in copies of trivia. Redundancy eats index. Each replication consumes capacity you could spend on something else. The art is placement. Which variables get broadcast at what fidelity across which paths. Error-correcting codes add just enough redundancy to beat the noise you face. Institutions should work the same way. Back up where failure is likely, compress where stability is high, sunset when copies outlive use. Translate ethics into physics. A promise that can't be checked is a private amplitude. A promise that leaves trails in public systems becomes part of the world. If you want to be trusted, build redundancy into claims, pre-registered analyses, versioned code, raw data with checksums, lab notebooks that survive a power cut. If you want to be kind, build redundancy into safety nets, multiple access points, clear fallbacks, distributed stewardship. Agency is not control, it's thoughtful replication under budget. Micro story. 2 medics in a crowded clinic build a paper triage when the network dies. Colored cards, simple marks, one redundancy, every patient gets a second glance. When the database returns, their scribbles translate cleanly. Lives hinged on a structure that copied decisions through air and sweat, not faith in a single channel. Map your interface. Keep a short list of what your patch can stabilize. Repeating transits, reproducible lines, cross-team shear, public commitments with receipts, and what it can't. Single-frame anomalies, one-off bursts with no corroboration, claims beyond causal reach. Spend bandwidth on the first, treat the second as cached. You'll still learn, you just won't mistake inference for fetch. Build retrieval ladders. Don't just post a figure. Post raw, scripts, environment files, checksums, and a README a stranger can run. Every rung multiplies the chance that someone else will fetch your past. You've turned a private amplitude into rendered history. Micro story. A small observatory catches a startling transient. Instead of chasing virality, they ping 3 arrays on other continents, open the pipeline, and wait an hour. Confirmations land. The light curve holds across instruments. When they publish, the signal is already rendered. Trust scales with copies, not drama. Practice the pause. Before you share that perfect clip, run a 30-second drill, source lineage, channel count, horizon fit. If any answer is mushy, wait. Accuracy pays compound interest in a rate-limited world. Nulls are answers. Smooth spectra and clean light curves aren't boring. They're receipts that minimal description travels far. Agency means accepting fences. Some caches aren't just inconvenient, they're outside your horizon forever. Put energy where redundancy can grow. Curricula, standards, open kits, libraries, scholarships that train hands that train hands. Hitch your pattern to systems built to replicate. You're not writing for eternity, you're writing for the next decoder. Micro story. A coder replaces a sprawling black box model with 3 transparent features tied to physics. Accuracy holds, calibration improves, adoption jumps because others can port it. The note at the end reads, "We can carry this into space." The stance is humble and stubborn. Humble about what you can't fetch. Stubborn about stabilizing what matters. Build copies where you can reach. Accept loss where you can't. Read constraints as guidance. Use budgets as design. In a universe that renders only what many channels can carry, agency is the craft of making meaning public. The test you can run, how to see the cache. Alright, no mysticism, no hand waving. Here, as how you catch the cache line in the wild. Start with the fetch versus infer test. Fetch means you can pull the same fact from multiple independent channels. Infer means you're reconstructing from priors and models. Treat every striking claim like a query. Ask, can I fetch this 3 different ways? If not, it's cached at best. Redundancy checks come in 3s. Spatial, different sites, latitudes, baselines. Modal, different wavelengths or sensing modes. Optical, radio, X-ray, gravitational, seismic. Method, distinct pipelines run by distinct teams. If a feature persists across all 3, it's rendered. If it lives in one corner with one code path, it's a ghost. Micro story. A grad student sees a faint spectral line near the floor. She reruns the reduction with a pre-registered pipeline, hands the raw to a colleague who uses a totally different toolkit, then requests a follow-up from a second telescope at another band. 2 out of 3 show nothing, the third wobbles. They drop the claim. Boring, no honest. The cache didn't promote. Time shift your queries. The shoreline moves. Design repeated pulls spaced in time. Real signals reproduce with phase and cadence. Artifacts drift with weather, calibration, or human attention. Schedule follow-ups before you publish. If the feature evaporates on night 2, scrawl cached in the margin and move on. Cross-confirm across wedges. Triangulate with communities that fail differently. Amateurs versus professional arrays. Open citizen classifications versus expert catalogs. International teams with different hardware and biases. You're not voting, you're separating instrument quirks from physics. If different wedges converge, you've fetched. Watch redundancy density. Ask, are there public logs, mirrored archives, versioned code? Does the record survive a power cut, a server swap, a team change? If you vanished, could a stranger recover this with posted materials? If no, you're staring at a single clip. Don't call it history. Instrument your pause. Build a 30-second drill before you share. Source lineage. Where's the primary data? Channel count. How many independent paths match? Horizon fit. Can my patch even stabilize this claim? If any answer is mushy, wait. Accuracy pays compound interest. Calibrate your priors publicly. Pre-register pipelines for analyses that could drift toward desired answers. Post hashes and timestamps. When the result lands, everyone sees what changed and why. You've turned method into a redundancy engine for honesty. Map the interface. Make a short list of what your patch can and cannot stabilize. Can, repeated transits at known periods. Spectral lines seen at multiple resolutions. Lensing shear fields matching across teams. Can't single-frame anomalies without raw access. One-off bursts no array can revisit. Claims outside causal reach. Tape that list near your screen. When a claim appears outside can, root it to infer. You still learn, you just won't pretend it's fetched. Practice debunk as public service. Do respectful autopsies on seductive errors. Recreate the edit or filter that made the illusion. Show the exact step where the artifact enters. Cross-compare with a clean pipeline to reveal the cut. You're not humiliating people, you're training a pause. Each teardown increases the redundancy of healthy skepticism. Build retrieval ladders. Don't just post glossy figures, post raw data or a path to it. Minimal working examples. Checksums for every artifact. A plain language, README a stranger can run. Every rung multiplies the chance someone else will fetch your past. You've turned a private amplitude into rendered history. Micro story. During a live stream, a supposed new planet pops from a transit pipeline. The host doesn't blast the alert. They open the vetting sheet. Odd even depth test, centroid shift check, archival images for background blends, follow-up planner. 90 minutes later, the centroid fails, background eclipsing binary. The chat thanks them anyway. Trust rises because the pause was real. Train your gut on nulls. Smooth spectra, clean light curves, a null dispersion. These are not disappointments. They're answers. Each constraint tightens the ledger and exposes where compression is doing work. Learn to clap for the absence of flicker. Do this long enough and you'll feel the cache line. Claims riding one fragile path taste brittle. Signals living across channels feel heavy. You're not guessing. You've built interface sense, the physics version of peripheral vision. It's the skill that lets you live well in a finite ledger. Here's the cut. Your past isn't stored. It persists as the parts you and the world wrote redundantly enough to survive. Everything else lives as clean compression you can predict, not replay. If this widened your map, subscribe and stay with us. Watch next our deep dive on dark energy, the quiet metronome at your horizon, and cue up the feature on black hole bookkeeping and the page curve. Drop the sharpest rendering question you want tested, and tell us the one ghost detail you pay to make public.